Okay, welcome to another tutorial. So for today, I'll be uh, doing a demonstration on how to perform one-way analysis of variance or one-way ANOVA, particularly between subjects or independent measures, one-way ANOVA using SPSS. So let's start with our problem. So generally we use one-way ANOVA when we have one independent variable and one dependent variable. So my independent variable here is relationship status, and for us to be able to use ANOVA, the independent variable must be a categorical variable, which means that the variations are in terms of categories and not a continuum of values. Whereas the dependent variable loneliness or the dependent variable in situations wherein we can use ANOVA to analyze the data should be continuous. Okay. Now, in particular, between subjects ANOVA is used when you have two samples or more, 3, 4, 5 samples, and these samples representing the levels of your categorical variable are separate, are separate groups, and no matching was done. So for relationship status, there are 3 levels. One is single, not in a relationship. The other one is single in a relationship, and the third one is married. So essentially the research question is asking if that kind of relationship status has some kind of impact on or can be predictive of one's level of loneliness. And another way of saying it basically would be that we'd like to know whether there is a there can be differences, or there's a variability among the sample means when it comes to loneliness between those who are married, single without relationship, and single with a relationship or in a relationship. So let's now go to our data. So this is our data. These are our variables: relationship status and loneliness, which means to say that ignore this variable for the meantime, stress. So ignore that. When we go to data to variable view, make sure that relationship status is tagged as a nominal measure, because relationship status is a nominal data. We've basically assigned one or we've basically coded the levels: single, not in a relationship; single, in a relationship; married, as 1, 2, and 3. So how did I do that? I just place the value of 1 and then enter single, not in a relationship, and then click add, and then it would appear there. So I've already labeled the values, so that's already good. And for loneliness, since loneliness is a continuous variable, so I assigned it as a scale measure. So let's now go to data view. So to analyze, to test our null hypothesis. Our null hypothesis, by the way, suggests that so it's a null hypothesis. It suggests that relationship status does not predict loneliness, or relationship status does not have an impact on one's level of loneliness. Okay, so click on analyze, compare means, one-way ANOVA. Now if it's the first time that you'll click that, it would look like this. So which goes which? For your dependent variable is loneliness, that's the one we're predicting, so place loneliness there. And then your factor is basically your independent variable, which is relationship status. So click this arrow so that it would go there. And then post hoc, I'll explain to you later on when we go to the results section what post hoc is, but I'll give a brief discussion on that now. So later on we'll essentially look at the mean loneliness of the three groups, the three samples. So we'll have a average loneliness of those who are single, not in a relationship, average loneliness of those who are single in a relationship, and average loneliness of those who are married. Now, ANOVA will tell us whether or not the variance among these means is greater than what we would expect by chance, or our error term, but it does not tell us where the actual difference is. Is it between, we have three means, but where's the actual difference? Is it between mean 1 and mean 2, or mean 1 or mean 3, or mean 2 and mean 3, so forth and so on? So this is the purpose of that, of post hoc tests. Now there are several options. Now, since that the sample sizes in this particular situation is not equal, I have three samples but they are of varying sample sizes, I'm choosing Shifei. Otherwise you can also choose, well, if you have the same sample size, maybe you can use Taki, but for the meantime I'll just use Shifei, which is very standard. And then click on options. So when you click options for the first time, nothing will be checked, so my suggestion is to check some of the essentials: descriptive, homogeneity of variance, and means plot, so that we'll have a graph. And then we click on continue, and then we click OK. So I will not click OK because my laptop is very slow, so just click OK, trust me on that. Click OK, and then when you do so, a certain output would appear like this. So the output has several parts. We have descriptives, test of homogeneity of variances, the null hypothesis test, ANOVA. We have the post hoc tests, and we have the means plot. So so let's first look at the descriptives. So these are your three samples representing three unknown populations: single, not in a relationship, single, in a relationship, and the group who are married. And these are their means. These means are in reference to your dependent variable, which is loneliness. And numerically, we can see that the average loneliness of those who are single, not in a relationship, is the highest, followed by single in a relationship, and followed by the last one. Numerically, the lowest scoring in loneliness would be the married. So essentially what we'd like to know is there is the differences among the means, is the variance among these means greater than what we would expect by chance? And that is what is answered by this particular table, ANOVA. But before that, we have here test of homogeneity of variances. So just look at this value, the significance value. It is now the significance value is also the same as your probability value or your p-value. It's just that in SPSS it's called significance value. So if it's 0.407, it's greater than our usual alpha of 0.05, which means that this is not significant, which means that there is no significant differences in the variance, which means that the variances are homogeneous, pretty much the same, which is good. Okay, we need that as a basic assumption for ANOVA. And now we have here the ANOVA test. Okay, so these are the respective sum of squares between groups, within, total. These are the degrees of freedom between groups, within groups, total, and these are the mean squares. And when you divide these mean squares, you will have your F ratio. So if you remember, the smaller, the closer the F ratio is to 1, the more likely that these two variances, so these are variances, are the same. So 21 is the variance, the measure of variance we expect by chance, and this one is a measure of the variance that we are observing among these three means. So the question is this far more greater than this particular measure of variance? And I think you know the answer already, judging from the discrepancy between the values. So when you divide these two, you'll get this value, your F ratio, which is our test statistic for ANOVA. And if you look at your significance value, or otherwise known as your p-value or probability value, it's less than 0.05. It's much less than 0.05, which tells us that our result is significant and that we can reject our null hypothesis. Now, our null hypothesis again states that relationship status does not have or cannot predict one's level of loneliness. And if we are rejecting that, therefore, this provides some evidence to the alternative, and the alternative is suggesting that relationship status does have an impact or can predict one's level of loneliness. So we have evidence for this particular alternative hypothesis. Now, how do you report the results, or how do you write this down in a report? So you can write this down as this. Sorry. So F, as in your F ratio, parentheses. Now, those values are these values: degrees of freedom 2, and then degrees of freedom within groups 1 to 1. Those are those values. And then the value of F, 5.401, then comma, probability value equals 0.006. There. Okay. So the ANOVA is saying that there is a significant difference. There are significant differences among these means. But the next question would be, where actually is the significant difference? Is it between 10 and 8, 8 and 7, 10 and 7? Where is the actual difference? And that question is answered by our Postop test. Okay. So in our Postop test, these are basically comparisons. The means of single not in a relationship is compared with the mean of single in a relationship, and then the means of single not in a relationship are compared with the mean of married. And what we have to look at are these values. So first, now maybe for you to be able to appreciate this, let's first look at our means plot. Okay. So the dots represent the mean loneliness of those who are single, not in a relationship. That's their mean, quite high. Single in a relationship, that's their mean. And married, this is their mean loneliness. Okay. Now let's go back to our Postop test. Okay. So single not in a relationship and single in a relationship, where is that? This one and this one, is there a significant difference? There, 0.045, which is less than our alpha, so the difference is significant. Next one, single not in a relationship and married. In our graph, where is that? Here, single not in a relationship and married, are they significantly different? The answer is a resounding yes. 0.013, less than R alpha. Now this one, single in a relationship, single not in a relationship, is pretty much the same as this one. Same value. Now the only thing we haven't compared is single in a relationship and married, which is this. Single not in a relationship and married. Is there a difference between those two means? Single in a relationship, married, boom, there is no significant difference. It is larger than 0.05. Okay, now the other ones, comparisons below, are basically the ones we've done above. This one is the same as this one. This one is the same as this one. Okay, so that's it. So I hope that so to summarize, one's relationship status can predict one's loneliness, and more specifically, it seems that those who are single, not in a relationship, are significantly more lonely than those who are single in a relationship and married. However, those who are the level of loneliness of those who are single in a relationship is not significantly different from the level of loneliness of those who are married. Okay. So I hope that this video has been useful, and stay tuned for my next videos. Thank you.